A real sugar molecule has been found between the stars. Not on a planet, not inside a meteorite, but floating in a cold cloud near the center of the Milky Way. The molecule is erythrulose, a 4-carbon sugar found on Earth in raspberries and some self-tanning products. Space has apparently opened a cosmetics department. Astronomers found it in a molecular cloud called G plus 0.693 minus 0.027, about 26,000 light-years away. This cloud is not empty darkness. It is a vast reservoir of gas, dust, ice-coated grains, shocks, radiation, and more than 180 modeled molecular species. The discovery matters because sugars are central to metabolism, cell structures, and genetic chemistry. But making useful amounts under early Earth conditions remains difficult. Scientists had already found sugars in meteorites and samples from asteroids. That suggested some of the chemistry might begin before those objects ever reached a planet. But until now, no true sugar had been securely identified in the interstellar medium itself. The cosmic pantry had ingredients, but no confirmed dessert. The team used 2 radio telescopes in Spain, the 40-meter Yebes telescope and the 30-meter IRAM telescope. They were not photographing tiny sugar crystals. Instead, they searched for radio frequency fingerprints produced as erythrulose molecules rotate in space. Every molecule has its own inconvenient barcode. Laboratory spectroscopy had already measured the frequencies erythrulose should produce. The astronomers compared those predictions with an ultra-sensitive survey spanning more than 91 gigahertz. They identified 12 groups of matching spectral lines representing 17 individual transitions. 6 of the cleanest features were dominated by erythrulose rather than nearby molecules. The probability that all 6 clean lines aligned by chance was estimated at about 0.2%. That is not absolute certainty, but it is strong statistical support. The first major reveal is simple. This is the first confirmed sugar in interstellar space, and it is not the smallest candidate scientists were looking for. 2 3-carbon sugars, glyceraldehyde and dihydroxyacetone, were not detected, yet the larger 4-carbon erythrulose appeared at least 8 to 17 times more abundant than their limits. Usually, adding carbon atoms makes interstellar molecules harder to find. Here, the galaxy skipped the beginner level and installed the more complicated package first. Erythrulose is also the largest non-cyclic molecule yet identified in the interstellar medium, the first detected there with 4 oxygen atoms, and only the second chiral molecule reported. Chiral means it can exist in mirror image forms like left and right hands, but the observations do not show which version dominates. So how could this sugar form at a place around 20 Kelvin where ordinary kitchen chemistry has filed a formal complaint? The researchers modeled reactions on icy dust grains. 2 simpler 2-carbon fragments related to glycol aldehyde and ethylene glycol can combine into 4-carbon erythrulose. Those ingredients are already abundant in the cloud. Quantum calculations found a favorable reaction pathway on amorphous water ice at temperatures typical of the galactic center. Computer simulations also produced erythrulose efficiently, sometimes more efficiently than the missing 3-carbon sugars. The result matches the direction of the observations, not every exact abundance. The models still overproduced some other sugars, showing that the chemical network is incomplete. Reaction rates, destruction pathways, and how much ice enters the gas remain uncertain. The cloud contains low-velocity shocks. Researchers think those shocks can knock or sputter part of the icy coating from dust grains and release molecules into the gas. Only a fraction of the ice may be released, and sugars can stick back onto grains or be destroyed. Interstellar chemistry includes a returns department with no receipt. Here is the second major reveal. The sugar was probably assembled before stars and planets formed. inside microscopic ice chemistry running in near darkness. That doesn't mean astronomers found life, alien jam, or a raspberry farm orbiting the galactic center. Erythrulose is a molecule, not a biological organism. But ketose sugars can rearrange into aldose sugars in water, and related sugars help build nucleic acids. That makes erythrulose a possible feedstock, not a proof of a specific origin story. Comets, asteroids, and meteorites can inherit material from ancient molecular clouds. In principle, they could deliver some prebiotic chemistry to young planets. The study demonstrates that a biologically relevant sugar can form without biology under interstellar conditions. Whether it significantly helped early Earth remains unresolved. So space was not waiting for planets to begin complicated chemistry. It was running molecular experiments on frozen dust grains 26,000 light-years away without supervision. Patch has filed the discovery under astronomy, chemistry, cosmetics, and pantry violations. What other ingredients for life are hiding inside the static between the stars?